Hey there, welcome to this video. We're going to graph sine and cosine functions with period change as well as some amplitude and midline mixed in. If you missed that video, go back and check out how the amplitude and midline affects a graph of sine and cosine. So let's go ahead and jump in. Just a reminder that a sinusoidal function are functions that involve sine or cosine, additive and multiplicative transformations of sine. And because sine and cosine are just a horizontal transformation of each other, they're both sinusoidal functions. Remember, here is the parameters, or here are the parameters for sine and cosine. We have a, b, there is a c parameter, which we'll talk about in a future video, and a d parameter. A is going to be amplitude. It's always the absolute value, so even if a is negative, your amplitude is the positive version of that. Your b value, this is what will be new to this lesson. This affects our period. It's going to affect the horizontal dilation of our graph. Okay, so if you see a bigger number there, it looks like a big multiplier, it's actually going to compress our graph, make it a smaller period. And if you see a fraction there, you're going to have an expanded, stretched horizontal dilation. Okay, remember cosine is the same thing, and they both have this d parameter, which is your midline. That's just the center of your graph. So as that goes up or down, that affects your graph. Okay, so just a quick note, here are how we can go ahead and utilize these parameters A, B, and D. And I will just say too, remember that if your A value is negative, that's going to cause a reflection across the x-axis, a vertical reflection. We know that sine will start at the midline, cosine will start at an extreme, a maximum normally, but if A is negative, then it will start at a minimum, okay? So, that being said, you can go ahead, you can pause the video and go ahead and kind of read this. This is kind of just talking about one method in order to graph sine and cosine, but I'll kind of cover that here in this video, okay? So, let's go ahead and look at example number 1. What I like to do with these problems is I like to identify our parameters. So, A is equal to -3, B is equal to 1/3, and then our D value is equal to 0. I don't have it. So that's our midline, y equals 0. And so you can expect the center of your graph to be on the x-axis. So here's our midline. I'll draw a dashed line for that midline. And our period, sorry, I'll do amplitude first. Amplitude is the absolute value of A, which is -3. So amplitude is a +3. And then period is going to be affected by the b value. So your period is 2 pi divided by whatever that is. And when we divide by a fraction, the absolute value of that, we get a multiplication of the reciprocal, so times 3. So our period is actually 6 pi. Oh my gosh. This period is stretched out. So we're going to expect a long wave here, okay? So let's go ahead and graph. What I like to do is the start. Where am I going to go ahead and start? Well, this is a cosine function. And cosine functions always start at extrema, maxes or mins. And because our A value is negative, since A is negative, I am going to start at the minimum. Okay, so I have a amplitude of 3. So from 0, 0, I'm going to go ahead and go down 3. My graph will start down here. Okay, start in an extrema for cosine, and then I have to go 6 pi. 6 pi. So notice though that I don't have 6 pi this direction. Okay. So I'll just kind of do this just so you can kind of see. This would be 1 pi. This would be 4 pi, 5 pi, and then maybe 6 pi. Way over here, 6 pi. And so I would repeat way over here. I'm just drawing that. You don't have to draw that. But just to think about, okay, if that's my period, halfway between is going to be the other extrema for cosine function, right? We split this into 5 key points. So first, cut this in half. That's going to be, for cosine, the other extrema. So at 3 pi, I'm going to have a maximum. And then we split these two intervals, okay? So I'll split this distance, which would be 1.5 pi, and that's going to be a midline for cosine. Okay, so for cosine, you get to extrema, and then in between is an extrema, where sine, we'll see in a little bit, is 3 midlines, so it kind of flips. Okay, and then in between 3 and 6, again, is going to be like 4.5 would also be a midline. Okay, so every 1.5, or I guess 3 units here, we have a key point. So we'll have midline, then we'll have maximum. Okay, and there's kind of our graph. So I'm going to go concave down, concave up, and I go off the graph. So concave up or concave down. Okay, so remember, your midlines are inflection points where you kind of change that concavity. It should not be pointy graphs. It should be smooth. All right, so there is our first look at having a changed period, that b value, how it changes our graph. Let's look at example 2 here. In example 2, my amplitude is 1. The period is going to be affected by this b value of 2, so 2 pi divided by 2. So our period is pi, and then our midline is equal to -3. So y equals -3. Okay, and so here's our midline. Okay, and this graph is a sine function, sine theta. So I'm going to go ahead and start at the midline. I'm going to start at the midline, which is right here at -3, and my period is pi. So I'm going to repeat at pi. Okay, so there's the end. And then, like I said, cosine, you have 3 extrema, whereas sine, you have 3 midline for your key points. So in the middle is going to be a midline. Okay, and then I'll go ahead and I'll graph my extrema. So sine, you go up 1, okay, so I'll just go in between, and then in between these values, I'll go in between for the minimum. So here's 1 cycle. Okay, man, and it's very, 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 very small. So that's what 1 cycle looks like, and we can go ahead and, repeat this. Okay, so it looks like every unit we have a midline. Okay, and then max, and then min, max, min, max, min, and we get this graph. Okay, so nothing too complicated with period change. It just kind of shortens or elongates your window for how often you start to repeat, right? So max, this would be a min, a max, min, max, min, max, min, max. Okay, and so here's our graph. Okay. I think this is, a practice problem. So go ahead, pause me, try this example, and then we'll talk about it here in a second. Okay, here's the parameters. A is 1.5, B is 2, and D is 2. 1.5, that's your amplitude. Your B value being 2 is actually going to shorten your period. Your period's pi, and then D is equal to 2. So we're shifted up to. Question here is, where do I start? Well, this is cosine. So I'm going to start at an extrema, and my A value is positive. So I'm starting at a maximum. So I'm going to go up 1.5 units, and then that will be my starting spot. And then I'm going to end at pi. So I repeat there, okay? Your other points in between, so directly in between is going to be a minimum, so down 1.5, okay? And then in between those will be midlines, So here's what 1 cycle of this graph should look like, okay? So hopefully you got something kind of similar. If not, fix it, and then I'll show you the rest, okay? So go ahead, pause me, and I'll show you the rest of this graph. Okay, and here you go. Every pi, you have a maximum. In between every pi half, you have a minimum. And in between those, the pi fourths, you would have all these midlines, okay? All right, here is the next practice problem. Go ahead, please pause me, and then I'll show you parameters and then kind of where you start on this one. All right, A value is -2. That means your amplitude's +2, but instead of going up for the sine function from the midline to the maximum, you're actually going to go down to the minimum. Okay, your b value is 1/4, so that actually elongates our period. We have 8 pi, so 2 pi divided by 1/4 is 2 pi times 4, 8 pi. And your midline's at -1, so we're shifted down. I'm starting at the midline because this is a sine function, and my period's 8 pi. 8 pi, oh my gosh, we're off the graph way over here. So I know in between it will be another midline, and then in between that would actually be your minimum. So you're starting from your minimum. Oh man, I can do better than that. Starting from your minimum and going back to your midline. Okay, and then the rest of this, it would go up to a maximum maybe right about here and do that. But in this graph, we're off the graph. Okay, but we could do it over here. And there you go. Okay, so not too complicated with period change. Hopefully it makes sense. All right, next, let's go ahead and look at some questions that appear on the AP exam involving these concepts. Example 1, the function r is given by r of x equals sine of pi x minus 1. Which of the following are the period and the midline of the function? Well, remember that your period is affected by the b value, and here b is equal to pi. So your period is going to be equal to 2 pi divided by b, which just gives us 2. So I can go ahead and I can cross out C and D, and then our D value actually gives us our midline. D is -1, so A would be your answer for that example. Okay? All right, here is another question. Go ahead, please pause me. Try this one. All right, which of the following are the period and amplitude of the function? Your amplitude is a +3. Always positive. It's never negative, so we'll throw those away. And then period, is it 1/2 or is it 8 pi? Well, I see a b value of pi/4, and remember, we always multiply 2 pi times that, the reciprocal, and so this is going to be equal to 8. Answer is going to be D. 2 pi divided by b gives you your period. Okay. All right, here is another example. Please go ahead, pause me. I want you to try this one. Okay. Hopefully on this one, you paid attention first to the D value. It is at 2. So you're looking for a midline of 2, which, I mean, looking at these, I feel like all of them, yeah, have a midline of 2. Nothing too crazy. But this is a cosine function, so cosines always start at a maximum, and our amplitude is 1. So it's not going to be b, because this would be an amplitude of 2, and it's not going to be d, because this one's starting at a midline. Notice it's starting at a midline. We can throw that one away. And okay, so it comes down to A and C, and so now we just have to use our B value. Our B value is pi/3, which means 2 pi times 3/pi will be our period. So we get a period of 6 when we cross cancel the pi. So which of these has a period of 6 repeats? Start at a max, ends at a max after 6. That answer is going to be C. Hopefully you got that one, okay? All right, next question. Let g be the function given by g of x equals cosine of x. The function h has the same amplitude as g, and the period of h is twice the period of g. Which of the following defines h in terms of g? So it's important to note that g is a cosine function, and they have the same amplitude, okay, which means their a values are the same. So right away, you can throw out C and D. Those are going to go away because your amplitude will be the same, not half of it or not 2 times it. But what does change is it says the period is twice the period of G. So G has a period that is 2 pi, and so that means H will have a period that is 4 pi. Okay, 4 pi. And so what we want is we want 2 pi divided by b to be equal to 4 pi. Okay, and so you could solve this rationally in order to identify what your b value is. So I guess we can go ahead and do this. We would get 4 pi times b equals 2 pi, and then we could divide by 4 pi. and this implies that b is equal to 2/4, which is 1/2. Okay. Okay, so we're going to select A. I mean, this also makes sense too, just kind of thinking about it conceptually. If I want a function h that has a period that's twice g, I'm looking for a parameter that looks like 1/2. Remember, these always do the opposite. They always do the reciprocal effect with horizontal multipliers. Okay, so A there. All right. Here's another question about increasing and decreasing rates. They give a graph of a sinusoidal function. Here is f, and they say which of the following is true. They say about the graph for f for 5 to 6. So please go ahead, pause me. I want you to try this one, and then I'll show you the answer here. Okay, hopefully you tried this. It's important, this goes kind of off the graph. So here's 4. That means this will be 5, and this will be 6. And I guess 2, I mean, the next one, well, we'll talk about this, 7. So kind of what's going to happen for our graph here is after 4 is I'm going down to a minimum, right? This is sinusoidal. So I'm going to go down to a minimum here. And then I'm going back to a midline. So our graph should look like this. Okay, and then for 7, I'm going to go up to a maximum. So it'll look like that. So what they're asking about is what's true about the graph for 5 to 6. So I really only care about this section of the graph. And is the graph increasing or decreasing? That's the first question. We're going up. So I'm going to cross out C and D. And is it increasing or decreasing at an increasing rate or a decreasing rate? Well, it's concave up. So by definition, we're at an increasing rate. Okay. Go ahead, pause me. Here is the last practice one, and they ask the same type of question, but for the interval 6 to 7. 6 to 7. Go ahead and answer that. All right, 6 to 7, 6, 7. Hopefully you went ahead and selected this interval right here, 6 to 7, and this is increasing, but it's concave down, so that means it's increasing at a decreasing rate. Increasing at a decreasing rate, B. Okay. All right, hopefully in this video you learned how we affect period by using a B parameter. It's always the reciprocal from what you see, okay? So if you see a 2, hey, that's actually scrunching your graph closer together. And then if you see like a fraction, like a 1/4, it's actually pulling your graph, stretching that graph, okay? Elongating the period. All right, hopefully you learned something. Give this video a thumbs up. I'll see you in the next lesson. Take care.